From the beautiful northern studios of Way Happy, this is Mr. Meyer in 3.6 Mathematics of Finance, or also known as the calculator section, because your calculator is your best friend in this section completely. So let's get started. This is all about money and different finance formulas. So the first one you see right here is a very common compound interest formula. It is used when you want to know how much money you're going to have after so many years, or maybe some way you're going to need to know that problem. The big thing is you know P, the amount you invest. A is the amount you get after the time's passed. K, how many times it is compounded per year. So that is very important. K, and then T is the time of years, and R is a rate, and that's always in decimal form like everything else that you've ever done. So make sure you know them all. All right, so look, as I read this, suppose you invest $2,000. That's my initial investment, so that's my principal. 7% is my rate, and so I'm going to change that to 0.07. And it is compounded monthly. That's 12 times a year, and I need to find it out after 6 years. There's your time. By the way, that was a K for those looking for variables, and this is T. So now I go ahead and I got to set this up correctly. So how much money, the amount I have is the original amount, and then 1 plus the rate. That feels really similar to exponential growth or decay, all over how many times you get that rate. So I get it 12 times a year. That's why I got to break it up into 12 parts, because they're not going to give me 7% each month. They're going to give me a 12th of 7% each month. And they're going to do that. I'll do that 12 times the number of years. And now you can see why your calculator is your friend. That is just one big nasty thing to type in. So that's what I will do. I will get Virtual Sheila up and running. And then I will go ahead and type this in, as I will just go 2,000 and then parentheses 1 plus. And then if you're scared of the fraction, you can use your fraction button and type in 0.07 over 12, and then close that parenthesis to the, and then make sure that that's, both staying in the exponent. For those of you who don't have the exponent button like this, make sure you put parentheses around the exponent also. So make sure it all gets typed in well and hit enter. And look at that. You will have at the end 30, 40, 21. So 30, 40, 21. And that is how much money you will have after 6 years invested in a bank account that gives you 7%. Nice. You just made $1,040.21 and did absolutely nothing but wait. All right. What about this one? Suppose you invest $3,000 at 6% compounded monthly. How long will it take to double? So again, my principal amount is going to be $3,000. My amount at the end to double, that's going to have to be $6,000. And I know my rate is 0.06 and my monthly is 12. So there you go. The only thing you don't know is time. So you're going to set this up. You're going to be, all right, 6,000 equals 3,000. That's the ending amount equals the initial amount. 1 plus the rate over the number of times compounded to the number of compounded and years. We don't know years. It's an exponent. Logarithms are going to be involved somewhere. All right, first things, though, let's solve this problem, right? Divide by 3,000. So when you divide by 3,000, 6,000 over 3,000 is 2. And that kind of makes sense because this is a doubling equation. And so therefore, I would want to know when it doubles. So it really didn't matter what the amounts were, because when you divided over, it would have been 2 no matter what. Now at this point, we see that exponent that we would definitely like to bring down. And so I believe I will log both sides, or you could do the rewrite, right? You do have a base, which that would be a nasty base, but it is. You can use the base of the log. You could, and then you have the exponent, and you have, every and what gets plugged into the log. So it's all there. Or you could just log both sides. You pick. It is not wrong either way. Now, again, sometimes I get lazy in my work and I just natural log both sides. Why? Because ln is easier for me to write than the word log. That's the only reason. So you can log both sides definitely, right? So I would have ln of 2 equals, I know there was no e in this problem. It was just because ln is shorter to write. And so I have 12t, because the exponent gets to come down, times the ln of I guess that should be a bracket, huh? ln of 1 plus 0.06 over 12. And there you have it. Now I am trying to get t by himself. So what am I going to divide by here? Well, I'm going to divide by whatever's not the t because it's all multiplied together. So 12 ln 1 plus 0.06 over 12. I'm going to divide that to both sides, and I'm going to figure out what the heck t is. So as I grab my calculator, one more time, I will do maybe a fraction button because I'm scared to death of what this is going to look like, because a lot of parentheses if I don't. So on the left side, we will have, what the heck did I just do? That's no good. Fire. There we go. Remember what I'm doing here is I'm dividing all of this over to here, and it's going to cancel all on this side and leave t alone. So what would it look like on my calculator? It would look like ln of 2, or log 2 if you were a normal person, over 12 ln, and nice that the calculator always puts that parenthesis in, 1 plus, now again I could do fraction, but I'm just going to do 0.06 divided by 12 because it's a simple little fraction. Close the parenthesis, hit enter, and say 11.58 years. So that is how long it would take for it to double. 11.58 years. And if you're somebody who wants to know how many months that is, take the 5.8, multiply it by 12, and see how many months that is. So there it is. 11.58 years is how long it will take for my money to double in that account. Now, sometimes you do not get interest every month or every day or every quarter, because those are all different numbers. Quarter would be would be 4 times, and every day would be 365. So your K values will always change depending on what it is, unless you see the word continuously. Now, continuously means I'm going to give you interest continuously. I will never not give you interest. It'll be a very small fraction of interest, but I will always give it to you. And guess what? That introduces Euler's number. So Euler's number is used, and you might have seen this equation PERT before. And what PERT does is it just says, hey, I'm going to give you interest constantly. So it's a little better deal for you, the borrower, or the person who's giving the money to the bank. So I ask you here, here's your initial amount. It is $1,000. 5 years, there's your time, and 5% is your rate. So 0.05 is your rate. And I ask you to do it twice. Once with so Bank of America offers it quarterly. Wells Fargo does it continuously. Obviously, continuously is better, but let's see how much better. Is it a big deal? So let's see. The amount I'm going to end with is 1,000. And then I'm using quarterly rate. So it's that other formula, 1 plus the rate. And we said we were going to do it quarterly. So that's 4 times a year, 4 to the 5th. So 5 years. So quarterly is 4 times a year. It was for 5 years. And now I will set up on Sheila my answer. Well, you know what? While I'm here, I'm going to set this one up too. So B is compounded continuously. The amount is equal to the principal, 1,000. Euler's number to the 5% for 5 years. And so that will give me the amount from Wells Fargo or whoever I said it was. So let's do the first one. 1,000, parenthesis 1 plus 0.05 over 4 to the 4 times 5 power. That is 128204. So that is 128204 from B of A. And Wells Fargo says, hey, look, put it in our account. You would get 1,000 Euler's number to the 0.05 times 5 power. They say, we'll give you 128403. 128403. And you can see the difference there. That is the difference between getting one that gives you interest every month, every quarter, and one that does it continuously. Very easy on your calculator. Now let me ask you a question, and I'll be back after the break. All right, nice work. Now, let's talk about annual percentage yield. You've seen on banks and everything that they're going to give you 5.25% on your savings account. You're like, sweet, but they're giving you that every month. So actually what happens is they're giving you a little interest, little money for keeping your money in their bank in January. And then in February, they're adding it to your account. So in February, they're going to give you 5.25%, or that fraction of 5.25%, the 12th of that. but they're giving it to you the money you had in the bank plus the little bit that they kicked in. So you're actually going to make a little better. And that's what annual percentage yield is. It says, hey, look, we're going to keep adding money to your account because you're leaving it in our bank. And so at the end of the year, how much did we actually give you? Did we give you 5.25 like we said, or did we give you more? And usually we give you more, right? Because you made interest on their money and your money. So how do you figure out what they actually did? And this is what you would want to compare when you go to banks. You actually don't, the rate's cool and it helps you find the yield, but the yield is what you really want to compare because that's the better deal for you in the long run. So how do I find this annual percentage yield? Piece of cake. Again, another formula so you can see your calculator is going to love you. And as you look at this example, here we go, right? So to find the annual percentage yield, I do 1 plus the rate. Our rate is 0.0525 over K, the number of times they said monthly, so 12, to the K power, so 12, minus 1. And that's it. That's your annual percentage yield. So boom, Sheila, where are you? And Sheila tells me, I go parenthesis, don't forget that parenthesis, 1 plus 0.0525 over 12 to the 12th power, and then bring it back down, minus 1. And it looks like it is a 5.378 yield. So that is a 5.378 or 5.378% yield. So what am I really making off of my money when I put it in their bank? I'm making 5.378% rather than 5.25. A lot of people don't understand that. So the banks just say, hey, look, here's your annual percentage rate. But if you figure out the yield, that's how much you will actually make off of your money. Deal, right? So go find the best yield. Now, annuities. As you get older, you should save for retirement. I know that sounds crazy at your age, but you should. Put a little bit of money all the way away all the time. Probably when you get your first big job, right? You should start doing that right away. Please remember that when you get hired. And just say, all right, I got a great salary now. And what I'm going to do is first put a little money in annuity every month. So it just builds and builds and builds because these things are exponential. And the longer they build, the more money you're going to have when you retire. And you're going to be that rich old guy, or old gal, which you're looking to be. And so make sure you invest in a yield. So here's the formula for it. R is the amount you're going to put in each month. I is a little different. It is right here. It's the rate over how often they're going to give you the interest. And N is the number of payments that you are willing to do. So if you're going to do it for 20 years, then we're going to have to figure out how many payments you make in 20 years or whatever. So here we go. Let us set up this beautiful annuity right here. So I say, I actually did this when I started teaching, I put $500 away in an account. I haven't been able to do it since I had kids, but at least I got started. I put $500 away. It earns 7%. Now our I value is the rate over K. So that is 0.07, and it's done quarterly, so over 4. So that's our I value. So I would have times, right? 1 plus 0.07 over 4. Now, how often is that? N is the number of times. So for 20 years, but if they're doing it 4 times a year for 20 years, our N value is going to be 80. And then minus 1 all over I, which is 0.07 over 4. And boom, there it is, right? Super mess. But again, we have calculators which do this great job for us. So 500 times, I'm going to go fraction button to save myself a headache of too many parentheses. 1 plus 0.07 over 4 to the 80th. Get down from there, minus 1 all over 0.07 over 4. And now this is me investing $500 a month for 20 years, right? That's a lot of money already, but them giving me interest each time along the way. How much would I have? Ends up to be $85,896.91. $85,896.91, I said. Beautiful. Now, if you're like me and you're just kind of curious, I paid $500 every month for 20 years. How much did I actually put in? Oh, every quarter. Shoot. I thought every month scared the heck out of me. Sorry, I must have said month along the way, and I'm very sorry. It was actually every quarter, and that didn't make sense. Notice, that doesn't make sense either. 500 4 times a year for 20 years, I put in $40,000. That's what I saved. But because they were giving me 7% every quarter, I actually ended up with 85,000. So I made $45,000 in those 20 years. That's a nice chunk, right? I saved 40,000. It cost me 40,000 to save 85,000. And that's why an annuity is so great. The longer you can do it, the better it is. If you graph that, you'll see it start to take off in the later years. So that's why you want to start early and let it build on itself as it goes on. All right. What about loans? Loans are the other thing you're going to have to do. You're going to have to buy a house. You're going to have to buy a car. So here's the formula for loan. Notice it's got a lot of the same stuff. And sometimes you don't know what you're finding. And this is fun. Say you go out and you saw a car was 21,000 and you were like, all right, I want to pay it off in 5 years, which is kind of normal for most people. So you're going to pay your loan off in 5 years. And if you wanted to set that up, here it is, kind of the same numbers involved, but this time we are trying to pay off 21,000. So that's the value of the car, 21,500. It's going to be equal to our monthly payment, which we do not know, and they will try to trick us in the dealings of the car by just making us focus on that. But you should go in being aware of that. 1 plus, now I is the rate over the time. So the rate is 2.9, so 0.029 over the time. We're going to do monthly payments. And that is going to get raised to how many payments you make in a 5-year period. So 12 payments in 5 years, that's 60 payments. And car people will tell you that they understand that number because they know there's 60 payments in their car. And we divide it by I, and now you just grab Sheila. So Sheila, help me out here. One more time. I have to just divide that whole fraction over. Oh my goodness. That is going to be gross, right? I'm trying to get R by itself. So what am I actually typing in? Now I am scared. It is going to be 21,500 divided by, now I'm going to do a parenthesis, and then maybe the fraction button to save my butt yet again. So 1 minus parenthesis 1 plus 0.029 over 12 to the negative 60. Make sure you use the negative button. All over 0.029 over 12. And then if you want, you can close your parenthesis, but no need to, but I will. 385.37. So to pay off this car, it will be 385.37. I will pay that amount per month for 5 years, and when it's all said and done, I will have paid off the car. Now again, if you're like me, one of the things I like to know is I made that payment for 60 months. So what did I pay? I paid $23,000 for that car. And you're saying, wait, it was 21,000. I didn't have all the money. So the bank was able to loan me the money, and I paid them back in little payments that I could afford, $385 a month. But notice I paid more for the car. So what? Are you going to save for your car and go pay cash for it? Or are you going to loan from the bank and then pay a little extra for it? Up to you. Have a great day. Stay happy. I know there's one more. We'll do it in class. Have a great day. Stay happy, and I'll see you tomorrow.